Developmental pathways are very important in eukaryotic organisms, as the repression or activation of certain ones can greatly alter their phenotypes. A model organism for developmental pathways is Drosophila melanogaster, for which example has one developmental pathway where Nanos represses hunchback, which activates anterior structures. Here, I'm going to use characters from Star Wars: A New Hope to explain how these regulatory relationships work. Okay, so here we have our Star Wars developmental pathway, where Princess Leia activates Han Solo, who represses stormtroopers, who represses Luke Skywalker, who represses the Death Star, or in the movie sense, destroys the Death Star. So if we have our pathway and Han Solo is removed, Luke does not blow up Death Star. And this is because the stormtroopers are not inhibited by Han Solo. So if Princess Leia is removed, Luke also does not blow up the Death Star, because Han Solo is not activated by Princess Leia, which we established before. Han Solo inhibits the stormtroopers. So if Han Solo isn't activated by Princess Leia, he will not inhibit the stormtroopers. So if the stormtroopers are removed, then Luke will destroy the Death Star, because there's no one inhibiting Luke from doing so. And then if we remove both Princess Leia and Han Solo, which we could call a double mutant in this situation, Luke does not blow up the Death Star. And this is because there's no one to inhibit the stormtroopers who inhibit Luke Skywalker from destroying the Death Star. And then if Han Solo and the stormtroopers are removed, another double mutant, Luke will destroy the Death Star, because now we only have Princess Leia directly activating Luke to destroy the Death Star.